So after talking about adding, let's talk about another important operational method that we know it as subtracting. So for the subtracting, first of all, we have to understand a couple of topics, a couple of different terms. What does it mean when we say that subtracting some number from another one? So obviously, as we know, that subtraction means that taking away a number or something that we call as quantity from another one in order to find the differences. What is that supposed to mean? Imagine that you do have two numbers. One number is 5 and another number is 2. By finding the subtraction between these two numbers, you can understand that if you would like to reach to a number 5 from number 2, you have to have 3 steps in order to do that. So in another point, subtraction is another form of addition. As we can see over here, 2 plus 3 is equals to 5. So by knowing this fact, let's just talk about it. The basic subtractions means that just a normal one or a normal number subtracting from another number. So imagine that you do have 85 and you would like to subtract the 32 out of it. So at the end, you do have the 53. It's just a very, very basic way of subtraction. Nothing happening, everything is easy, we don't have any borrowing parts. What does that mean by borrowing parts? Let's just talk about the subtraction a little bit in more details. So when we're talking about 85 subtracted by 32, it is something like this. 85, 32 subtract. Again, as I was just telling you, the most common way is just about the column one. It means that we write down each number based on the value points under another number. So when I do have the subtraction of 85 and 32, the 2 would be subtracted from 5 because it is written down beneath number 5, both of them are units, and 3 subtracted by 8. Nothing strange is happening. 2 subtracted by 5 is 3. 3 subtracted by 8 is just 5. So I know for a fact. But imagine that we do have a point that when we are going to subtract the first number, which is, for instance, at this point, the first number, which is number 2, from the second number, which is 5. Right now it is easy, right? But imagine that we do have a case that the first number is bigger than the second number. What we should do on that time? At this point, we do have a technique that we call as a borrowing technique. What does that? When you need to subtract a larger number or a larger digit from the smaller one, instead of just doing it as a normal way, you are going to borrow from the column on the left. What is that supposed to mean? Let's just look at example. Imagine that I do have 52 subtracted by 7. So obviously I have to write down like this, right? So I do have the 52, which is the tens, and 2 is just ones or units. And I do have 7, which doesn't have any kind of tens or 100. So I have to write it down like this. 52 subtracted by 7. So let's see, what should I do? The way that I know, just like the previous part, is that I have to subtract 7 from 2. But here's the issue. 7 is bigger than 2. Imagine that you do have 2 oranges and you would like to borrow 7 oranges out of it. Can you do that? Obviously not. You're going to face a problem. In order to fix this problem, I'm going to borrow a number or borrow 1 point from number 5. What does that mean? It means that my number 5, which actually contains 4 and 1, is going to borrow or is going to lend one of its points to the next part. What would happen on that point? On that point, my number 5 is going to be converted to number 4. But what would happen to number 2? Right now, 2 has 1 point or 1 value from the 10th. So obviously, if I move this 1 to this place, it's going to be converted as 10. Right now, I do have what? I do have 12. Can I do the subtraction? Yes. 7 subtracted by 12 is 5. What is happening on the left side? On the left side, I don't have the 5 anymore because one of them was borrowed by the unit, so I do have 4, and at the end, I do have 45. Again, it wasn't that kind of challenging. But imagine that I do have 3 numbers like this. 805 subtracted by 629. Let's just talk about this one a little bit more. So again, the numbers, what? 802, let me just write down over here, the number that I have was 805, 629. 805, 629. I'm going to subtract these two numbers from together. So again, we are going to talk about only this example, and after that move to the next part. So as we can see, we have to write down those numbers column, one column at a time. 5 and 9 in one column, 0 and 2 in another column, 8 and 6 in another column. So let's see how we can do that. I'm going to subtract 9 from 5. I know I cannot do that. Why? Because 5 doesn't have enough numbers inside itself. So 5 should borrow a number from the left side, which is 0. But in our surprise, the 0 doesn't have anything to lend, or the 0 doesn't have anything for 5 in order to borrow it from. So this 0 is going to borrow a number from 8. What would happen at this time? Let me just write it down like this: 805, 629. At this point, my 8 is going to lend a number or a unit to number 0, which we know right now, this my 0 is going to be converted as what? This 0 is going to be converted to 100. What does that mean, 100? Because as we know, the place value of 8 was 800. So if I borrow one number out of it, what would happen? My 8 is going to be converted to 7, and my 0 is going to be converted to 100. But I know if I put the 100 in the place value of 10, this guy is going to be converted to 10. Is that good? So 10, right now, I do have 10 in the tens. But again, I know number 5 needs something. So I'm going to borrow one number out of this 10 and give it to 5. So two things would happen. 5 would be converted to 15, and 10 is going to be converted to 9. So what is happening right now? At this point, I do have something like this. I do have 7, I do have 9, I do have 15, and I'm going to subtract this number again out of it. 9 subtracted by 15 is going to be 6. 2 subtracted by 9 is going to be 7. And 6 subtracted by 7 is going to be 1. So I do have 176 as my final number, the way that we see over here. The important part is about borrowing. When one number doesn't have enough value inside itself, in order to be borrowed from the second number, we have to borrow it from another number. If you're not succeed to get it from the first number, we have to get it from another number. If you couldn't succeed from another number, we have to do it so on and so forth. But again, remember, whenever you're using the carrying method, whenever you're borrowing a number out of a bigger number, you also have to convert it to a smaller one. You also have to convert it to a smaller one, so on and so forth. So this is everything that you have to know about some kind of subtraction, about the real world application. If I want to make some changes, if I, for instance, when you pay $20 and the items, the cost $12.50, so obviously $12.50 would be subtracted by 20. About the time calculation, so finding how many hours, for example, between these two periods of time, and so on and so forth. That was the example we had. So let's talk about the multiplication. So what does it mean when we are talking about multiplication? Obviously, you know, the very first thing, 2 multiplied by 2 is equals to 4. Very basic thing of multiplication. So what does it mean by multiplication, by the way? Multiplication is representing the addition, and it also mentioned that has many efficient techniques in order to do that. So get rid of this part. So multiplication means that if I want to multiply one number by, or some kind of one number by another number, or if I want to add one number by itself, how many times? So when we do have 2 times 2 is equals to 4, it means that I'm going to add the 2 by itself 2 times. If I do have 3 times 4, actually I'm going to add 3 4 times. So multiplication is another way of addition. But we do have different kind of ways for the multiplication itself. The first one is about the times table. What does that mean? The timetable is the table that maybe some of you heard about that from our elementary school, is about a number from 1 to 10 and another number to 10. And this is going to resemble a table for me. So this table is going to show what would happen between, for example, number 2 and 2. 2 times 2, 4. 3, 3. 3 times 3 is 9. So this is the times table, and most of the time they will ask you to remember that. That's a very good thing to remember that one. You can find it easily on the internet. Take some time, try to remember all of the numbers. Those are very basic things that you have to know in order to do the multiplication. Another way that we do have, there are some tricks. The first one is about just a quick trace. This means that there are some patterns in multiplication. For instance, multiplying by 9. So what does that mean? It means that imagine that you do have two numbers and one of them is 9. For instance, 9 times 7. So 9 times 7 is 63. We know it from the times table. If you are not familiar with that, you can use the calculator. Interesting thing that you can see, the final answer 6 plus 3 is 9. It means that whatever number that you multiplied by 9 itself, at the end, you do have a number that if you add all of those digits, despite of the place value system, if you add them like the unit wise, you can have a number that is going to again be 9 itself. That's a very interesting thing. Another way that is very important is about the long multiplication. It means that instead of just multiplying one digit by two digit, one digit by one digit, we do have multiple digit by multiple digit that has to be done step by step. Today, at this point, we are going to talk about only simple ones, and in the future slides, or the future videos, we are going to talk about how complicated they could be. For instance, I do have the 12 multiplied by 9. So at this point, what is happening? We are going to use a very, very simple trick. What is that trick? So let's just do it this way. Imagine that I do have 12 multiplied by 9. And right now it is very challenging for me to know how. But I can do one thing. Would it be okay if I say that 12 multiplied by 9 means that I have to add 12 9 times by itself? Is that right? So this is also okay if I say that if I add 12 10 times, and if I subtract another 12 out of it, I can find my number. Okay, so 12 multiplied by 10, when I do have 12 10 times, should be added by itself. It means that 12 multiplied by 10, that I do have 120. But this is not the final answer. I still have to subtract 12 out of it. So 120 subtracted by 12, I know, wait, 120 subtracted by 12. How I can do that? We know 2 cannot be subtracted from 0. You have to borrow 1 from this 10s and move it over here. So I do have 10. What would happen to 2? This 2 would be converted to 1. So I do have 10 over here. 2 subtracted by 10, which is over here, is going to be 8. 1 subtracted by 1 is going to be 0. And after that, I do have a 0 for the hundreds. For the first number, 0 subtracted by 1 would be 108. So at the end, 12 times 9 is going to be 108. That's a very simple trick, by the way. Again, in some kind of more advanced video, I will talk about all of the ways, but this is another important operation. So real world application, we do have, for instance, 6 items and 350 cents each of them. So I have to multiply them. About the area, how we can some kind of multiply one number by another when we are talking about the money itself, and so on and so forth. So let's talk about another way, or another mysterious way. So let's talk about the next one, which is the division. So first of all, we have to understand the division. What does that mean? The division is finding out how many times one number is going to contain between another number. What does that mean? It means that when I'm dividing 4 by 2 and the answer is 2, I'm trying to find how many different, or how many times the 2 is repeated inside the number 4. So when I do have 2 multiplied by 2, I'm going to reach to 4 again. It means that there are 2 times of 2 is repeated inside the number 4. So this is a very simple way of showing the division itself. So the way that is going to be written down is going to A divided by B, or A divided by B, like this. It means that 4 divided by 2, or 4 divided by 2. So these are two ways. Another way that we do have, or another subject that we do have, is about the long divisions. And it needs step-by-step process, which is going to be outside of this scope. So we are going to talk about it maybe in the future ones. But right now, there's something like this that we know and we can consider that. So it's about the long divisions. It means that, for instance, I do have it, for instance, 105 divided by 25. Again, we are going to talk about it in the more advanced topics, which is going to be about the long divisions. But right now, consider that. Another thing that we do have is about remainders. What does that mean? Imagine that you do have a number. I do have 15 divided by 2. Obviously, if you do that in your calculator, you can see a number which is going to be 2. Let's just do it right now, shall we? 15 divided by 2. 7.5. So as you can see over here, I do have the 7.5 as my final answer. 15 divided by 2 is 7.5, but it's not a number that I'm looking for, because most of the time when we are talking about divisions, we are talking about getting a real value or giving an integer. For example, number 7, not 7.5, which we maybe know it as decimal point. So at this point, we say that we do have remainders. It means that if I divide 15 by 2, I'm looking for how many times this 2 is repeated inside the number 15. Based on that, I know there are 7 full 2's in number 15 plus 1. So 7 multiplied by 2 plus 1. This 1 is something that we call as remainder. Let's do it with 17 divided by 5. It means that right now in 17, I do have 3, 5, or 5 is repeated 3 times, plus another 2 that I know it as remainder. So this part is about advanced part. I just put an example over here. But for the division of the long part, each section has different names that we will talk about it in the future. So another thing that we have to know is about order of operation. What does that supposed to mean? It means that imagine that you do have a case that you have all of those 4 operations side by each other without any parentheses, without any part that could divide those. I do have 6 plus 2 multiplied by 3 divided by 4 and so on and so forth. How I can find which one of these operations should be done at the beginning. So that's why we do have something, we call it as order of operation or PEMDAS, which for the abbreviation. What does that mean? It means that at this point, I do have the parentheses at the beginning, or my first way. I do have exponents, which we don't know it right now, for second. I'm going to do the multiplication for the third part, and I'm going to do the additions for the fourth section. The one way that you can memorize that is just by using this kind of cute way, is that please excuse my dear Aunt Sally. So I do have PEMDAS. So let's just solve the question that we were talking about it like this. So what do I have? I do have 6 plus 2 multiply 3 divided by 4. So how I can do this one? First of all, I have to do the parentheses. Since I don't have any parentheses, I'm going to do the exponent. I'm going to do the exponents. And I don't have any exponents, so I do have to do the multiplication. But as you can see over here, I do have multiplication and division side by side. Their priority is the same. How I can do that? From left to right. It means that first of all, I have to do the division, and after that, I have to do the, first of all, I have to do the multiplication, sorry, and after that, I have to do the division. 2 times 3 is 6. 6 divided by 4, if you just do the calculation, it would be 1.5, and 1.5 plus 6 would be 7.5. So this is the way that we do that. This is something that we call it as a PEMDAS, or the order of operation. Again, as a very, very basic example over here, I do have 6 plus 2 multiplied by 3. 2 multiplied by 3 is 6, plus 5 is equals to 11. So I have to be careful if I do it on another way. What does that mean? Instead of just having the 6 plus 2 multiplied by 3 at the beginning and add it with 5, if I do it 5 plus 2 and multiply by 3, I do have a 21, which is the wrong answer. So the right answer would be 11. So let's just look at this way. 4 plus 6 divided by 2, subtracted this one should be, move over here, subtracted by 1. How I can do that? Based on the order of operation, I know that 6 should be divided by 2, 3. 4 plus 3 subtracted by 1. Maybe some of you would ask why you didn't do you didn't do the subtract at the beginning, and after that you do the addition. Because again, we know the order of operation, adding and subtracting, they do have the same priority. And if I want to do it, that one should be from left to right. So at this point, I do have 4 plus 3 subtracted by 1, which is going to be number 6. Another thing that we are going to consider over here is about the fractions. Again, we are not going to talk some kind of in detail about the fraction, but we are going to see that what is happening inside the fraction. What is that supposed to mean? If you remember, we had something from our 4 categories. The number 4 was about the rational numbers. It means that any number can be written as fractions, or if any number can be written as fraction, would be considered as a fraction, not as some kind of a rational number. So for the fraction ones, means that I do have two important parts. As you just remember, A divided by B. But let's just name them. What does that supposed to mean, A and B? A is a number that would be written on the top, but we call it as the numerator. That this number is above the line that shows how many some kind of parts we have. So this is something that we call as a numerator. That's so. The numerator is going to be on the top, something that we call as numerator. So this numerator is going to be above the line and shows how many parts we have. Another number that is going to be underneath this division or underneath of this line is coming as denominator. So this number below shows the total equal parts. Again, remember that I'm trying to divide two numbers side by side. 3 divided by 4. I know I don't have a good answer for that, but this is the way that we write down the divisions. So type of fractions. There are three types of fractions that we do have. The first one is a proper fraction. It means that the numerator, or the numerator, because sometimes it's hard to pronounce, the numerator is smaller than denominator. So at this point, I do have a proper fraction. Another one that I do have improper fraction. So as you can see over here, the numerator is bigger than denominator. So this is something that we call as improper fraction. I believe you can say why, because 7 divided by 4 can be written as 7 divided by 4 can be written as 1 multiplied by 4 plus 3. That's why we call it as improper fraction. Another one that we do have as a mixed number. What does that supposed to mean? It means that 1 and 3 over 4. So this is something that we call as a mixed one. So 1 is considered as a whole number, which we know about the whole number. 3 divided by 4 is just a fraction. So I can write this down as 1, 4, 3 divided by 4. Or if you want to write it down, you can write it like this. 4 divided by 4, because of this 4, plus 3 divided by 4. And again, what do I have? I do have 7 over 4. That's why I do have this one as an improper fraction and this one as the mixed number. We're going to talk about it in detail in the future parts. So about the real world example, imagine that you're doing the cooking and you have the half cup of sugar, you have the 3 over 4 of spoon of the salt, whatever. About the timing, you do have the quarter, and about the shopping, you have this kind of so on and so forth. So let's talk about this fraction visual-wise, that how we can some kind of show them and how we can add them, subtract them, dividing them, and etc. So about the fractions, the first one, let's just put our concentration over here. So as you can see over here about the addition or example for addition of this fraction, I do have 1 over 4, which is like this. Imagine that 1 is going to be one part and 4 is the whole number. So 1 is the part and 4 is the whole number. So if I do have a circle and if I divide that one by 4 different sections, one part out of 4 part is this guy, plus 2 out of 4. Again, imagine that I'm dividing this into 4 sections and I do have 2 out of 4. So obviously if I combine this guy and this guy, I do have 3 out of 4. So this is easy, right? So right now, again, we are going to talk about the simple things. So addition means that I'm going to add 2 fractions together. So they do have the same denominator, like 1 over 4 and 2 over 4. They do have the same denominator. And the only thing that we have to do is just add the numerators. So I do have 3 divided by 4. So the different denominators, we have to something that we call as the common denominator. Again, this is something advanced. We're going to talk about it for the next slide. So about the subtracting. So subtracting fractions, again, do the same thing. Imagine that I do have 3 divided by 4 subtracted by 1 over 4. How I can do that? Again, I have to write down the denominator, which is number 4, subtract 1 out of 3, which is 2 over 4. If they do have the different denominators, you have to find the common denominators, and we will talk about it. A multiplication is some kind of the simplest way that you can do is just having 1, this is the one fraction, multiplied by the second fraction. What do you have? You do have 1 multiplied by 2, which is 2, divided by 2 multiplied by 3. The numerator and denominator are going to be multiplied together. 1 and 2, 3, 2 over 6. So multiply the numerators together and multiply the denominator. And at the end, if you want, you can simplify the results. Again, this is not the thing you are going to cover. But dividing the fraction is going to be more advanced topic, and I think it would be better to talk about it for the next part. But we do have it that we can just kind of divide two fractions side by side. And the last part would be about decimal fundamentals. So again, we're going to talk a little bit about the basic parts, and for the future videos, we're going to talk about in more details. So what is decimals? Let's just talk about the fundamentals. Now, understanding the decimals. The decimals are a way of writing fractions with denominators of 10, 100, 1000, and etc. Then I'm going to use the decimal point in order to separate the whole numbers from the fraction point. What is that supposed to mean? So if you remember, when we were talking about the divisions, the one part that we consider was the simple divisions. 12 divided by 2, which equals to 6, right? We don't have any remainders, everything was easy. But what would happen if I do have 10 divided by 4? If you just do this one in your calculators, you do have a number that we call it as a decimal number, 2.5. What does that supposed to mean? It means that we don't have 2 or 3 whole 4s inside the 10. We do have a number between. Between that 10 could be equals at 2. 2 of 4 plus number of 2, which we know as a remainder. Instead of just writing down like this, that 10 is equals to 2 of 4s plus 2 as remainders, we are going to use the decimal points, 2.5. 2 is something that we know as a whole numbers, and 2, another one, which is going to be a fraction. Or I can write it down as 2 plus 2 divided by 4. 2 is a whole number, and 2 divided by 4 is the fraction. Or we know it as 2, something like this that we learned so far. So instead of just writing down like fractions, and it could be a little bit complicated for us, we're going to write it down as decimal. Imagine that I do have a number that 5 points, which this decimal part is going to be called as points. 5.7 is going to be read as 5.7 or 5 and 7 tenths. What does that mean? 7 divided by 10, which is 7 tenths. What about this one? 3.14 or 3 and 14 hundredths. What does that mean? The 14 hundredths, it's 14 divided by 100. Or this one, which we call it as 0.625 or 625 thousandths. Again, we are going to talk about it in the future, but this is the way that we call these numbers. So we call about this one, and if you remember, when we were talking about numbers, the basic numbers, for example, 325, we talked about the place value system. We also do have the same thing as a place value system in our work or in decimal ones. It means that the whole number and after the decimal point, which we can call as a decimal part, they also do have the place value system. So for the whole number, it's not that easy. It is so simple. So for example, I do have 1/10, and I do have the 0 as ones, as units. But on another hand, for my number, for the decimal points, I do have 5 as tenth, and I do have 7 as hundredths. So if I combine these two numbers together, and if I want to write it down, it would be something like this. 1 as tenth, 0 as units, and after that decimal point, I do have 5 as tenth and 7 as hundredths. So by considering this fact, I know that the whole number has a place value system, and also decimal part is also had the place value system as well. So again, for instance, where we're going to use that, we do have $5.75. 5 means that 5 whole dollars, and 75 cents means that actually 75 out of 100 cents, which each 100 cents is going to be $1, 75 cents out of dollar. So we are going to use that in a lot of application and a lot of